Hi, welcome back. Now I have a set of data of the Great Orion Nebula that I took a couple of weeks ago. I took this image as a test subject and I was going for just 5-second subexposures, so the total integration time is just under 30 minutes. It's not a lot of data, but today we can together see how much we can pull out of this image. And if you're interested, I have a previous video where I was going through sorting and stacking all the subframes of this master file. I'll link it up somewhere here, so if you're interested, take a look at it. Without further ado, let's go. Okay, here we are in PixInsight. I just opened the master file of the Orion Nebula. This is a 29.5 minutes integration using 5-second subframes, and the data is still in its pure linear phase. I will start by renaming the file to something simple like RGB, and let's take a look using STF auto stretch. Well, I have to say, when I first auto-stretched this file, I was actually amazed on how much detail there is. I mean, it's not the best image in the world, I'm not going to win any awards for this one, but you can see that there's a lot of nebulosity, a lot of H-alpha, a lot of dark structure, so I will do my best to maximize the detail, contrast, and the overall quality. This master file came out of WBPP automatically cropped, as we can see in the image name. I was using only the UV IR cut filter with a color RGB camera, and the image is already plate solved. So the first step will be BlurXterminator, and I will use the new AI version 4. And for the first step, I will select this option that says correct only. This sharpens the image a little bit, but what it mainly does, it corrects for the optical aberrations and guiding errors. As we can see, I will zoom a fair amount on this star, and we can see that from the right side, the blue channel is a little bit misaligned, and the star on the left side is completely white. So when I use this correct only option, this should go away on all of these stars. And yes, the result is stunning. We can have a look at some before and afters on these large stars. You can see that the star is now perfectly round and white. But before, again, we have some blue haze on the left side and some yellow haze on the left side. This is after. Before and after. Now that all these stars are perfectly corrected, we can go to the next step, which is spectrophotometric color calibration. Selecting a region of the image where there are no stars, no nebulosity. For the background neutralization, drag the preview to the region of interest and drag the triangle to the image. Now that SPCC is done, I can go back to screen transfer function and actually link the channels, hit the nuke, and see what we are working with. Normally the next step would be some kind of background extraction like DBE or ABE or Grexpert, but in this case it is actually pretty difficult because the whole frame is pretty much filled up with nebulosity, so we are not actually working with a pure background here, so I decided to skip this step. And anyway, there is no obvious background gradient. Now that the image is color corrected, we will get back to BlurXterminator when I will once again select the new AI version 4, and this time we are actually going to sharpen stars and sharpen non-stellar. I will raise the parameters a little bit to sharpen stars 0.3 and sharpen non-stellar 0.95. Well, this is a fair bit aggressive, but I think we will get good results. Okay, and the results are absolutely amazing as usual. Keep in mind that this is just 30 minutes of data, so don't expect much, but it's looking great. You can see some before and after. I hope you can see it through the compression of YouTube. Now this is in the territory of pixel peeping, but anyway, take a look at the detail. Amazing. We can proceed to NoiseXterminator. Now this is a little bit of mystery to me, but this image, even with such low integration time, there is not a lot of noise. So I will use denoise 0.7 to 0.75 as usual and drag the triangle to the image. We are now completely noise free, great. We will proceed to removing the stars. What we want to do is to generate the star image and unscreen the stars, so we can work on both images separately. Okay, we now have our starless image and our stars only image. Now I will minimize the stars for now and work on the starless image. Well, normally I don't do this, but for this image I kind of like how STF actually represents the image, so I will use these exact parameters to stretch my image. For that I'm going to go to All Processes and Histogram Transformation. I will reset the tool, select the RGB image, go to Screen Transfer function and drag the triangle down to Histogram Transformation. Let go, and now I will drag the triangle from the histogram transformation process down to the image. Great, and now when I disable STF, the image is permanently stretched exactly like it was displayed by STF. That was real quick and it's looking great. Okay, let's proceed with curves. I'm not going to use any kind of mask for this moment. I can open the real-time preview to see immediately how my changes are affecting the image, and I will play a little bit with RGB/K and saturation. Great, now that we have improved the overall contrast of the image a little bit, we can proceed to taming down this super bright core of the nebula. For that I'm going to use a range mask to select just these top brightest parts. The range selection process can be found under All Processes and somewhere here, Range Selection. Okay, I will open the real-time preview. I will mess with the sliders until I get something that looks like a selection just of the core. Okay, something like this. Hit the square to apply. We will drag the identificator right here and drop it on the image. The mask is now active and we can tell that by this identificator being orange in color. Okay, I will get back to curves, open the real-time preview, select luminance and drag the curve a little bit to the downside, and we can immediately see that the luminance of the core is getting lower and lower. We don't want to overdo that, because then it will be real obvious where the boundaries of the masks are and it will look real bad and unnatural. So take some time with this. Increase the saturation in the core maybe, before and after. Does it look natural? Let me know in the comments. The image still looks a little bit dull. To increase the contrast, we could potentially use something like Unsharp Mask, or even better and more simple, we can go to Script, Utilities and select Dark Structure Enhance. Just using the default settings, I will hit OK and see what happens. Okay, the image looks immediately a little bit more dramatic, which is what we are looking for, because astrophotography is one big drama. So I would consider this image to be maybe finalized. I will just spend a couple of more minutes with curves to get the contrast just to the point where I like it. I'll be back. Okay, we are now done with curves, so we can get back to RGB stars image. And you know what? For the simplicity of this tutorial, I will again choose Histogram Transformation and just accept the STF values to stretch the image. So in Histogram Transformation window, I will have to select RGB stars. First, I need to reset the tool, sorry, and drag the triangle from STF down here and the triangle from Histogram Transformation to the image itself. Great, the image is now stretched. Don't worry about these alien looking artifacts here, just disable the stretch and everything is just fine. So what I like to do with the star image first is the use of SCNR will get rid of the green color cast. Some stars are having this green kind of halo, which is of course not natural, so using the amount of 1 maybe seemed a little bit aggressive, but that works fine for me. I will drag the triangle and get rid of the green color immediately. Now we can see that the star color and the star halo turn blue, which is good. Great. Now to combine these two images, I will use as usually the Screen Stars script. I like to use this script because it's really easy. You just need to select the starless view, which in our case is RGB stars, and the stars view is RGB_stars. We will create a new image and hit the green tick to apply. Close the script, and this is our result. So there we have it. It was a quick and dirty process, but we got the job done. In a couple of seconds I will share an image that looks a little bit better. I took some more time with it off the camera, but I promise you it's the same data and same process is used. So thank you all for watching, I hope you learned something new today, and as always, clear skies.